In this video, we are going to look at a single input neuron. So let's write that down. Single input neuron. So a single input neuron would have just one input, and let's try and draw to see how that would look like. So let's say this is our input P. We just have one input, and this input, as we have seen previously, is sort of used as a way used to multiply with weight. So we have the weight W that goes for that input, and then there is a term called bias that is also used along with this. So let's see that the bias is 1, and so both of these, we are showing lines coming into this box which has this summation sign. So what we are trying to say here is that we take the W, multiply it with the input P, so that's this part right here, and then we take this B, the second part, and add it here. So that's what we are trying to do inside of this summation box that is shown above. So let's put this as plus B. Now after the summation, what we get is the value for n, and as we have seen, that is what we called as the net input. And net input to what? Net input to a transfer functions. And so here we are drawing another box which is denoted as f, and the transfer function can be anything, could be uh, purelin or sigmoid, and we'll see some of the transfer functions we are going to use in this series. So that's what this is. The n goes as input to the transfer function f, and then comes the output, which is a. Now in all of this initial part, which is the p, that is our input, and then what we have is this part right there, that is our neuron. That's our neuron, and then beyond that, which is right here, that is our output, and you can show that down here as well. So that's the input part, then this is the neuron part, and then that's the output part. So this output could be input, and so it depends where this a is. Now as far as the equations go, that is the wp plus b, that is what we call as the net input. So net input n is equal to w times p plus b, where w is the weight, that is importance for a particular input. And because we have a single input, we just have the letter p without any super subscripts. So this is our input, and b is the bias, which is used for thresholding or moving the decision line, and we'll see that as we go. So once we have the input, which is this one, that is then net input that can be brought into the function. So we can say to get the value of f, we need to put the n in the transfer function, and so essentially a is nothing but f, which gets the input w dot p plus b, and this right here is the equation that represents the single input neuron output, and the activation or the output for calculated output for the single input neuron. Now let's say if we plug in some values, what will happen? So if we have, let's try this out. Let's say if we have the values of values given, let's say W is 0.5, the value for P is, let's say, 2.0, and the value for B is let's say 1 in that case. And let's say that our transfer function F is a simple hard limb function. So hard limb function, and that is from the MATLAB. What I mean here is that for a, so for a equal to 0, a is equal to 0 if n is less than 0, and a is equal to 1 if n is greater than or equal to 0. So that's the function we are going to use. Now in our case, when we have this relation, we are going to calculate a, which is going to be equal to 0. So this is f 0.5 times p is 2.0 plus b, which is 1, and so this is going to be equal to um, 2 times 5 is 10, and we have that one decimal, so that this becomes 1, and they have 1 plus 1 is 2, and so what we are looking for is f of 2. And if we look at the hard limb, we see that if the value of n, so this is inside here, what we are calculating is the value for n. So here, as you can see, n is equal to 2, right? And so because n is greater than 0, this condition would apply, and therefore because n is greater than equal to 0, we say that a is equal to 1, and therefore the output of this output of this single input neuron with these values given here is going to be a is equal to 1, and that's how the single input neuron works. So key takeaway points are as follows. We have an input, which is right here, and the input, we multiply it with the weight, then we add the bias term to that product to get us the value for the net input n, which we then feed into a transfer function f, which could be any type of transfer function such as hard limb, and that will then give us an output which we denote as a, which uh, which is sort of the prediction of this particular single input neuron. That was it for this video. I'd really like to know how you find the explanation. Was it helpful? Was it confusing? And I'll try to improve the explanations as we go in this series. So next video, what we are going to do is build on this single input neuron and see how we can build something new.